close your eyes and imagine a planet where the ground beneath your feet is so heavy that you'd weigh 2 or 3 times what you do on Earth. Where the sky is dominated by a massive close-in star and where the air is thick, making it hard to breathe. Welcome to the world of super-Earths, a new class of planets that are Earth-like but more massive than our own, a world where the giants rule. This is Gliese 667cc, a super-Earth, about 4 times the mass of Earth. Super-Earths are a fascinating new class of planets that share many similarities with Earth, but their sheer size and gravity make them unique. They can have rocky, icy, or a combination of both surfaces, with geological features that can be more extreme and noticeable than those found on Earth. Mountains, volcanoes, and canyons on these planets could be taller, larger, and more spectacular than anything we've seen on our own planet. One of the most intriguing things about super-Earths is that they are far more common in the galaxy than Earth-like planets. In fact, they're estimated to make up a significant portion of the planets in our galaxy, with studies suggesting that 1/3 of all stars in the Milky Way could have super-Earths in their habitable zones. While many super-Earths are not considered habitable in the traditional sense, some of them may be super-habitable. These planets have the potential to be even more suitable for life than Earth itself. They could be older, larger, warmer, wetter, with higher levels of oxygen, stronger magnetic fields, and a longer living star. Picture yourself standing on the surface of Gliese 667cc. As you look up to the sky, you'll see a massive, close-in star dominating the horizon, which is the parent star of the exoplanet and 2 other stars illuminating the sky that make up the triple star system. Gliese 667cc completes 1 orbit around its star in just under 30 days. It's located just about 7 million kilometers, or less than 5 million miles. Mercury is 57 million kilometers from the Sun by comparison. Its star, a red dwarf, belongs to the M-type star category, which are the coolest and most abundant stars in the universe, with lifetimes that can last trillions of years. These stars have their habitable zone very close to the surface. For comparison, our Sun is a G-type star. These are medium-sized stars with surface temperatures between 5,000 and 6,000 Kelvin. They emit radiation mostly in the yellow part of the spectrum and have lifetimes of around 10 billion years. Interestingly, K-stars, which have properties intermediate of G and M stars, are considered to be the sweet spot for habitability. They are abundant in the galaxy and pump up the chances of finding life. On Earth, it took 3.5 billion years for complex life and 4 billion years for advanced life, such as humans, to evolve. If life were to originate on a planet orbiting a K-star, there would be more time for evolution to take place compared to Earth. This is because super-Earths, which are planets larger than Earth but smaller than Neptune, could provide more land, mass, and habitat, making them more suitable for life to thrive. Additionally, super-habitable worlds may have higher gravity and a thicker atmosphere, which could help spread beneficial organisms, potentially leading to a more diverse ecosystem. Planetary scientists suggest that the sweet spot age for a super-habitable exoplanet is around 5 to 8 billion years, which would provide enough time for complex and advanced life forms to develop. Planets with more moisture and an average surface temperature 8 degrees Fahrenheit warmer than Earth may be more habitable because warmer and wetter climates tend to have more diverse life. In fact, some super-habitable planets may even resemble Earth during the Carboniferous period, about 359 million years ago, when the climate was similar to a tropical rainforest. There might even be phytoplankton covering large areas of the ocean, perhaps as large as continents on Earth. With the possibility of such diverse and complex life forms on super-habitable exoplanets, the next generation of enormous ground-based telescopes, including the 39-meter Extremely Large Telescope and the 25.4-meter Giant Magellan Telescope, will have the highest prospects of discovering indications of life in the atmospheres of these planets. These telescopes, currently under construction, are expected to gather data by the end of the decade. Astronomers are aware that life's essential components are present in the universe. But livable does not imply inhabited, and even the most habitable planet may not be inhabited. It's plausible that life on Earth was truly an exceptional accident until scientists discover proof of life elsewhere in the universe. If scientists continue to hunt for signs of life on these extremely livable super-Earths over the following years and don't find any, people might be forced to believe that the universe is a lonely place.